Okay, now that we have talked about what acids and bases are and the definitions, the different definitions for those, we want to look at how do we actually get the number that shows up on the pH scale. How do we find that number? So to review, what are pH and pOH? pH and pOH are basically ratings that tell you the potential for a hydrogen atom or ions in a solution. That's the pH, means potential of hydrogen. pOH is the opposite. It's the potential of hydroxide in a solution. So we know that when we have an acid, the pH is going to be a lower number, which means there is actually a higher potential of hydrogen. As the pH increases, the pOH decreases. And since the scale of pH is from 0 to 14, we can always add the two numbers together. pH plus pOH is going to be equal to 14. I know we don't usually refer to a pOH scale because everything is rated in the scale of pH. So pOH is basically just the inverse of that. So where do the numbers come from on this scale? Well, we need to realize that the pH scale is actually a logarithmic scale. That means we have to use a logarithm to find the numbers. What is a logarithm, you may ask? Well, a logarithm is basically a way to tell how many of one number we need to multiply in order to get another number. Another way to look at that is to say that a logarithm tells you what exponent you need to change one number into another number. So, for example, if I had an equation that looked like this, 10 to the x power equals 100. You already are thinking in your mind probably that 10 squared is equal to 100, and you're correct. 10 squared is equal to 100. The logarithm of 100 with a base of 10 is 2. So notice what we did here. The log base 10 tells me that 10 is the base number here. 100 is what I get by raising 10 to the specified power. And 2 is the exponent that I need in order to get that answer. So it's basically just a backwards way of writing an exponent. Now, when we're in base 10, we don't actually have to write log 10. We assume that logs are in base 10 unless otherwise noted. So all we really need to write is log 100 equals 2. So how can I use a logarithm to calculate pH or pOH? Well, there are some formulas that you need to know. The first formula is the autoionization constant of water. And basically, hydrogen ions and hydroxide ions in water are equal. That's why water is a neutral substance. It's pH neutral because it has the same amount of both. We can multiply those numbers together, and that gives us the total constant of hydroxide and hydrogen ions in the water. So in this case, 1 times 10 to the negative 7 power is the value for each one of those. We multiply those together and we get 1 times 10 to the negative 14 power. That's Kw. That's the autoionization constant of water. All you need to remember is that that's the number for water, and you need to remember the formula. Kw equals the molarity of hydrogen ions times the molarity of hydroxide ions. And that way you can use this to solve for an unknown. The second thing we need to know is the pH formula. The pH formula is pH equals the negative log of the molarity of the hydrogen ions in solution. The pOH formula is pretty much the same as the pH formula, except we are looking for the negative log of the hydroxide ions in the solution. And finally, remember that pH plus pOH always equals 14. Now let's use these formulas to calculate a pH. For example, find the pH of a solution if the hydrogen ion concentration equals 2.6 times 10 to the negative 6 molar. So write our formula down. pH equals negative log of hydrogen ions. So substitute in 2.6 times 10 to the negative 6 power for hydrogen ions, and all you have to do now is literally punch this into the calculator. So you're going to hit the negative log button and type 2.6 times 10 and then the little up arrow for raising it to the negative 6 power. And press enter and you get 5.6, and that's the pH of this solution. Now what if they don't give you the number of hydrogen ions and they give you the number of hydroxide ions instead? Find pH when hydroxide concentration is equal to 6.4 times 10 to the negative 12 molar. Well, now we need to use the pOH formula, which again, negative log of the hydroxide ions concentration. So substitute your number in there. pOH equals negative log of 6.4 times 10 to the negative 12 power. Punch that into your calculator and press enter and you get a pOH of 11.19. But that's not what I'm looking for. I want the pH. Now I need the other formula, pH plus pOH equals 14, and plug in my pOH value. So pH equals 14 minus 11.19, which means that the pH of this solution is equal to 2.81. One more, and that is, how can I use an antilog to find the ion concentration of hydrogen ions? So basically what we're looking for is the ion concentration if I know the pH. Find hydrogen ions of a solution if the pH is 4.97. So write your formula again. pH equals negative log of hydrogen ions. I need to rearrange my formula. So the opposite of log of hydrogen ions would be 10 to the negative pH power equals the number of hydrogen ions. So when I rearrange, I can now just plug in numbers. I don't know the hydrogen ions, but I do know the pH. So hydrogen ion concentration equals 10 to the negative 4.97 power. Plug that into the calculator and I get a hydrogen ion concentration of 1.1 times 10 to the negative 5 power. And that's how we use logarithms to calculate pH, pOH, and ion concentration.